There have been several enhancements and new features to improve 3D views in Chief Architect X16. Let's begin with ray tracing for Macs. The big news with X16 is that we have implemented physically based ray tracing on Mac computers. Mac computers that support the system requirements now have the same GPU ray tracing as PCs. You can refer to our computer systems blog article with comparable metrics of PC and Mac GPU ray tracing to learn more. If you are a Mac user, PBR ray tracing is now available. In X16 PBR ray tracing, we have exposed path tracing settings that simulate light transport throughout a scene using physically based principles. A control for opaque bounces defines the number of times light bounces off opaque materials. A setting of 1 bounce consists of no more than 2 hits to the material. The control for transmissive and specular defines the number of bounces for translucent, transparent, and mirror material surfaces before terminating the light's path. Ideally, each path would continue until the remaining light contribution is negligible or it exits the scene. However, this can be computationally intensive, so we have exposed the bounce controls to help you optimize the best rendering results. Settings of 1 opaque bounce and 4 specular bounces would be similar to X15's behavior when approximate additional bounces is checked. Emissive materials produce light in GPU ray trace views. These are known as area lights. Any material that is set to be emissive, fireplaces, TV screens, light bulb glass, and vertical rope lights, will contribute light based on the emissive value. The quality of physically based ray trace views can be significantly improved with area lights. In addition, a single lighting model can be used for both a standard render and a PBR render. Why? These standard renders use punctual lighting sources, which can be tuned for these views and not set overly bright. The PBR model uses the emissive area lights for its lighting model. The emissivity of the lights are derived from the light's color and brightness by default. You can override the default and use emissive materials with custom values to tune your lighting model. This was done for these LED hoop lights. Now you can edit in a standard view that looks good with faster response times and then switch over to a PBR view for final editing or creating realistic renderings for your clients. High dynamic range images are now supported for backdrops. HDR backdrops are spherical and contribute environment lighting effects to both 3D scenes and material previews. Since HDR images are able to more accurately store the differences in brightness between objects over LDR images, it can greatly enhance indirect lighting for render scenes. There are new HDR backdrops in the bonus library, or you can import your own. An HDR image can be used for a backdrop in any rendering technique, but it will only be in HDR for GPU ray trace views. In other render techniques, the HDR image will be tone mapped and converted into an LDR image before being displayed in the view as a backdrop. In ray trace 3D scenes, select an HDR backdrop and then it will automatically mark the spherical backdrop option. In the camera settings is the option to only use the backdrop for lighting. In the render scene, the backdrop can be rotated side to side with the Rotate tool under the camera view options. HDR images can add significantly to the quality of your render scenes, in particular for exterior renderings. Chief renderings can be exported as an HDR image. I'll export this scene as a 360 panoramic image, choosing to make it a backdrop with an HDR file type. HDR images can be used to preview materials using a new drop-down for the backdrop type. Using your model to preview materials can assist to show lighting used from your scene. To de-emphasize the backdrop, you can use the blur setting in your appearance preference so you can focus on seeing the material using your model's lighting. Light can pass through translucent materials such as curtains, glass, and other materials in physically based ray trace views. New properties have been added to the translucent material class. The thin setting treats the front and back surface as one, ideal for fabrics and foliage. There are transmission settings for color maps, roughness, and roughness maps that can adjust the way light is transmitted through the materials, in particular for plants. You will also find enhanced material maps for normal, ambient occlusion, metal, and new maps for translucent and clear coat. The new clear coat material property can be used to create a glossy or built-up sheen in 3D views using PBR ray trace. Adding a clear coat property to materials will result in a more accurate modeling of the materials, like car paint or anything with a layer of polish. You can specify roughness values and attach roughness or normal maps separately for the clear layer. Tone mapping is the process of taking high dynamic rendering lighting values produced during rendering and mapping them to the range for display on the screen. Chief Architect has supported a process known as Hable since it introduced physically based rendering. In X16, we have implemented an additional Academy color encoding system tone mapping process that tends to produce more saturated colors and darker darks than Hable. These two-tone mapping approaches can produce different results that may vary depending on your scene. They can be found in the PBR and clay rendering technique cameras. For watercolor renders, you can change the base rendering technique from standard to physically based or clay to achieve different rendering styles. The cross-section slider tool that has worked with most of the rendering techniques has been enabled to work in both orthographic and vector views. Dimensions can now be created in 3D views. Automatic dimensions for interior, exterior, and story pole work similar to the way they work in plan views and elevations. With manual dimensions, you can click to establish the dimension plane and then click and drag to create the dimension. There are dimension tools in the Edit toolbar for setting an object in component mode and to adjust the offset distance. Editing the dimension is similar to the other views, with the added ability to position the dimension in 3D space. You can click on Object and create dimensions with a new dimension tool in the Edit toolbar. In the camera specification is a new setting for dimension defaults. On the General panel in the 3D display section, you can configure the extensions and labels. Using 3D dimensions, you can now create renderings with a defined sense of space for your clients. There are many great new features in Chief Architect X16, and you can expect to see it in late Q2 of 2024. And remember, all new software subscriptions include support and software assurance that provides access to all of our latest software. So, if you are not currently a customer, get started today with Chief Architect.